The question is to find double integral over a triangular region. All right, let's go through this together. First step is to understand the triangle. We're given 3 points that form a triangle. Point P is at the origin, which is 0, 0. Point Q is 3 units to the right on the x-axis, so that's 3, 0. And point R is 1 unit to the right and 2 units up, so that's 1, 2. If you imagine connecting these 3 points, you'll see a triangle where the base lies flat along the x-axis between points P and Q, and the top of the triangle reaches up to point R. Next step is to find the equations of the triangle's sides. Now, let's find the equations of the 3 lines that form the triangle's edges. First, the line connecting point P to point R. Since point P is at 0, 0 and point R is at 1, 2, we can calculate the slope by taking 2 minus 0 divided by 1 minus 0, which gives us a slope of 2. So this line has the form y equals 2 times x. Next, the line from point R to point Q. The slope here is 0 minus 2 divided by 3 minus 1, which equals negative 1. Using point slope form, we get y equals negative x plus 3. Finally, the bottom of the triangle, which connects points P and Q, lies along the x-axis. So that line is simply y equals 0. Next, decide the order of integration. Now we have to choose whether to integrate with respect to x first or y first. In this case, it's easier to integrate with respect to x first. That means we'll fix a y value and see how x changes as we move across the triangle horizontally. Looking at the triangle, for a fixed y between 0 and 2, the left edge of the triangle is the line y equals 2x. Solving that for x, we get x equals y divided by 2. The right edge is the line y equals negative x plus 3. Solving for x again, we get x equals 3 minus y. So for a fixed y value, x goes from y divided by 2 on the left to 3 minus y on the right. And y ranges from 0 at the bottom up to 2 at the top. Next step is to set up the integral. Now, we're ready to write down the double integral. We integrate from y equals 0 to y equals 2. For each y value in that range, we integrate x from y divided by 2 to 3 minus y. The integrand, the function we're integrating, is just the variable y. And since we're integrating with respect to x first, we treat y like a constant during that inner integration. Next step is to integrate with respect to x. So we now compute the inner integral. We're integrating y with respect to x from x equals y divided by 2 to x equals 3 minus y. Since y is a constant in this step, we can factor it out. So we get y times the difference between the upper and lower bounds, which is 3 minus y divided by 2. Let's simplify that expression. 3 minus y over 2 becomes 3 minus 1 and a half times y. So this entire inner integral becomes y times the quantity 3 minus 1 and a half times y. Multiply out and we get 3y minus 1.5y squared. Lastly, integrate with respect to y. Now we compute the outer integral, which is the integral from y equals 0 to y equals 2 of the expression 3y minus 1.5y squared. To integrate 3y, we raise the exponent by 1 and divide, giving 1.5y squared. To integrate 1.5y squared, we get 1/2 y cubed. So now we evaluate 1.5y squared minus 1/2 y cubed from y equals 0 to y equals 2. Plug in y equals 2. 1.5 times 4 is 6. 1/2 times 8 is 4. So 6 minus 4 equals 2. At y equals 0, everything is 0. So the final result is 2. Here's the key technique we used. First, sketch or imagine the triangle. It really helps to see the boundaries. Identify the lines forming the edges and solve for x or y if needed. Choose the order of integration that give you simple bounds. In this case, integrating with respect to x first was easier. Treat variables correctly. During inner integration, the other variable is just a constant. Keep your expressions clean and simplify as you go. That's it for this question. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.